transferring sorry. So we are basically we are imitating the intelligence of human behavior into our machines, right? We are just transferring the intelligence. And again, as I said, we cannot do 100% transformation, but we try to transfer as much as possible to machine. That's the biggest umbrella. And when you see AI, within AI, the next level is the machine learning, right? So basically what it does is allows the system to automatically. So what we do, we collect a large set of data set, right? Data coming from, you name it. You collect data, and with the data, you automatically learn and improve from the experience. So you take a set of data set and you make it learn from the data, and then use that intelligence for future predictive analysis. So that's what we do in machine learning. And when you go the next level within machine learning, there's a deep learning, which is very, very highly, basically we are transferring our brain's neural network, right? Or what we do with the neural network, we are transforming into the deep learning process where it's the algorithm, complex algorithms and a deep neural net to train a model. So we use several layers of neural network process and make that, using the data set we are making to learn. So if anybody is asking you and looking you from AI, machine learning and deep learning, this is just kind of a classifying, I'm just putting in 3 different umbrella, and don't get, whenever you see this, hear this acronym names, don't get puzzled. It's a pretty straightforward. You're just trying to make the system or computers or machines learn from a set of data set. That's a simple explanation, right? We'll go to the Q&A. At the end of the meeting, we'll have a Q&A session. And if you have any questions, just note down. And also, I'll leave my email ID, and for any upcoming questions, you can reach to me. But keep all the questions and keep it with you until the end of the meeting. All right. So when you look at the definition, simple definition, right? So this is not new. Whenever you see the name, it's not new. It's Arthur Samuel. He wrote in 1959. It exists like I was puzzled with this year, right? 1959. It's a field of study that gives computers, right? Computers the ability to learn without being explicitly programmed. So what does it mean? We are not using any explicit programs. We are making it to learn without data. So we are making the system to learn with set of data set. So when you look at the objectives of machine learning, there are a couple of objectives, right? One is first thing is classify the data based on models. So you are making a classification for the respective model, and don't get deep into algorithm. When I talk about algorithm models, don't go very deep. I'm just giving an idea how that algorithm model looks like. But you don't need to go deeper, right? I'm just going to cover the basic, and I'll show you a simple way of what we do with this, building models. And what you do by classification, what we do is we classify that model and use that model for future prediction for future outcomes, right? So the idea is a simple use case. I'll talk in my sensor data. Simple use case is you get all data set, right? Incoming data set from various sensor data. And our idea is we collect this data, and if any new information comes in future, when the data goes through, and we build a model, right? We build a model, and any future data come in, we'll send the data to the model and ask, hey, what will be the outcome, right? For example, my truck is going on the road, and for some reason, there is a system failure, right? One of the engine brakes, or I have a problem with my brakes. So if I get a set of data set coming from the truck, and I can accurately predict predict that the truck need a maintenance, and I can ask my driver to go to the nearest maintenance shop and fix the truck. So with this, I'm kind of basically I'm fixing my truck immediately before going for an breakdown or any accidents. So many things I'm fixing before causing trouble. So I'm just giving a quick example, but we will go in deep in upcoming demo. So if you look at machine learning types, right, there are basically, when you look at types, there are two types, right? One is supervised learning and another is unsupervised. So when you look at supervised, basically we are building and developing a predict model based on the both input and output data, right? So we are getting a set of data set coming from the system. And what we do, we label the data. We will talk about labeling in the next, the upcoming session. So we label the data, and what we do is there are in supervised learning there are two types, right? One is classification, and another is regression. So in classification is more like the naive based, basically like classify yes or no kind of thing, right? If the truck needs a maintenance or it doesn't need a maintenance, like a true or false kind of classify the model. And whereas in regression is more like play with the numbers, right? Like a weather prediction or sale of a house in a particular location. So these are all playing with the numbers. So that's called regression. So it comes in the classification, regression, supervised learning. And in unsupervised learning, so basically unsupervised is a group of internal data based only on input data set, right? There is no output data. The data coming in. So unsupervised learning is a much complicated process. So because the data will be continuously feeding in, and you need to classify based on incoming data. You have to classify and build that build the model accordingly. And a simple example for the process is clustering. So we call k-means cluster, which is basically used for in the unsupervised learning process. So for today's topic, right, I'll be covering supervised learning. I'm not going to talk about unsupervised because it's just a next example. But more, the demo will be more covering with the supervised, especially in the supervised. I'll give you a demo on the classification model, so which will help you to understand, and then you can apply the same analogy for rest of the the process. All right. So when you look at the steps, right, in machine learning steps, these are the core 6 steps involved in machine learning. If you take any machine learning process, so the first step is collecting data. Anything you talk about, it requires data, a set of data set. So first process is you need to collect the data from any machine you talk about. And second is the clean and transformation, right? You are transforming the data. Cleaning the data means you fix, if any, by looking at the data, you look at if any null values or if the value is right, wrong, and you will be applying a lot of statistics, right? Statistics and probability. And that's where we spend a lot of time. I mean, if you look at data science folks, right? In any industry, data science folks, most of the time they spend time in collecting data and cleaning and transformation, right? That's where they spend most of the time. So once the data is cleansed and transformed, we explore that using the visualized process, see what it is, what the data is, how many, for example, how many null, what is the min, max, variation. You ask for any questions, you will explore the data, right? In that step, third step. And fourth step is the building model. That's the brain. That's where you spend time in building the model. That's the brain of machine learning. Basically, you are teaching the machine with this exploring data. You are teaching the machine to build a model, right? That's basically, I would say that the brain. And from there, the next goes to evaluate, right? We'll evaluate the data set, and that's where evaluate, and then we'll go for deploying, right? And in the deployment step, that's where we talk about more like prediction. So we will be collecting data set, input data set, and we build this model up to the evaluation. We will, do it with the data set, what we know. And then once it's deployed, any new data set comes in, that will be basically, that will go and use that from the model, whatever it learned from the model, and it will predict based on, this is right, this is wrong, or this house will be costing this much, and you name for it. So that's where that that's a and with once it's deployed, that's it. That's your model is built, and you can run through the process for any new data set. So these are the core 6 steps we cover in the machine learning steps, right? And if you look at the setup, right, simple setup for machine learning, as I said, all this, the 6 steps I covered, right? 6 steps will be done in a different stages, right? Any complex and any industry you go for and learn about machine learning. These are the processes. Whatever I'm showing, this is a process. So basically, when you look at it, a data set, right? A data set, you're feeding a data set of data into a pipe. Basically, we call Kafka API, which is like a ETL transformation system. You feed the data into Kafka, and through the queue, you collect the data continuously, and then you feed the data to a process which we call in this case Spark streaming. And basically, that is the brain. That's where that model is built. And once the model is built, we'll store in a Mapper or it's a JSON database, which will be more like unstructured. And then you go to the JSON, and then you basically run using Spark SQL or Apache or BI. Any BI tools you use, you drill down into the map JSON database for any predictive or new analysis. So this is a setup going from industry standard, what all the industries uses traditional, and if you look at that, it requires a lot of skill set. I mean, it's not easy. I mean, you need to be good in database. You need to know a lot of SQLs, and you need to know how to run with the SQLs with unstructured and structured data, and Spark, Apache, experience, and then also in the Kafka API, you'll be playing more like a Java, right? You need to be well versed with Java programming, and you'll be playing with a lot of programming when the data is feeding through that Kafka. So, yeah, multi-skill set folks we need in each area to build a machine learning model, and that's how that traditional model goes through, right? And when I talk about in-database machine learning, right? So in this, the idea is what we do is, instead of going through all this complex setup, what we do is the data is stored in a database, right? So database, and lately all the database vendors, name it Oracle. I will go through the slide next, the next few slides. Most of the databases are made as like AI. They introduce AI into the database. So the idea is you don't need to use complex Kafka process for streaming or Spark or multi-step process. You just store the data in a same system. You collect the data and store it in the same system, and basically you will be running your AI predictive analysis directly on the data set, right? That's the idea. And what we do with this is you don't need to multi-skill set folks, right? As long as you know SQL, our database and SQL, you can play with the data and build a predictive modeling within database itself. So things are making more simple here, right? You don't need to be a well-versed Java programmer. You don't need to do Apache, or you don't need to be a heavy BI business intelligence query person, right? I mean, you'll do, as long as you know SQL, basic SQL, you'll be able to do some predictive analysis on existing model. So when you look for supporting databases for AI, there are a lot of industry, like a Vertica, Blazing SQL, Google Cloud, BigQuery, and IBM DB2, Kinetica, Microsoft SQL Server, Oracle, and Amazon Redshift, right? We're all coming up with, right now they're embedding their databases as AI, artificial intelligence. And right now we are concentrating more on IBM DB2. For this session, we are using IBM server, which is in University of Oregon. Right now it's in Oregon. And so with the IBM DB2, I will show you what we do with how we build machine learning models. And as I said, all these vendors, they all support this support building in database machine learning, and our more concentration is on IBM DB2. Okay. So when you look at challenges, benefits, right? One of the simple benefit when you're, this is the challenge. I'm just comparing the benefit of two different processes, which I showed you using the traditional approach and in database machine learning. So basically, the first challenge is the talent gap. I mean, industries needs more talents. If you want to build a complex system, you need more talent. Whereas in database machine learning, as long as you have a SQL interface and a machine learning deployment, you know the process, you can easily go ahead and build the top. Very easy, pretty straightforward to build the model. And sensitive data, right? I mean, the data is more sensitive in the traditional process. Here we visualize data access in the model building. Through the model building process, you can with simple handshake, you can visualize. And you don't need to transfer the data, right? If you're sitting in a traditional way, sitting in the database, you need to take the data out, cleanse it, and you need to run through a Kafka process to Apache for building a model. But whereas in database machine learning, there is no data transfer. Data is sitting there in the traditional database, and then you go and build the model there itself. And it's a challenge. Costly infrastructure is very costly, the traditional. And here, there is a simple structure on the data is sitting in the database, and then we are secure and scalable, right? You can, as long as when I mean scalable, you talk about some thousands and millions of data and billions, right? Now we are talking about data sets of terabytes of data. So you can scale the DB2 infrastructure just by adding more core, processors as well as memory, and you build the bigger server, and then you can do wonders with the learning process. And then inference performance, because traditional process, you run in a Windows server or you build a multi-layer process, a lot of issues will come with the performance. Whereas in building within database with the native and the open source models, there won't be any performance impact, right? I mean, right now the model I'm showing you is built on IBM AX server on Power 9, and IBM is coming up with the Power 10 processor pretty soon, where we will be seeing wonders, right? With the GPU processor and Power 10, you name it. I mean, the performance-wise, will be the number one in building modeling, right? And integration with machine learning is very challenges in the traditional approach, whereas, as I said, in DB2, it's a SQL-based interference query. So as long as you know SQL, boom, you can build models. And this is what survey says, right? The worldwide survey says 66, any data set you look at it. I mean, as I said, when you look at data is, I mean, if you're even computers or the database guys, you know that data comes from several sources, right? And then we store the data. Just anytime we look at the data, that's like two types, right? One is structured, another is unstructured. Anything in the relational data stored in the tables in a database, right? When you talk about all the databases, we store relational data, which is structured data. And whereas when you look at the data coming from Facebook, Twitter, or you talk about all the, outside process, they're all like unstructured data. You get data as a blob, images, you get data as an email, you get data as like a Facebook comments and notes. So these are all like, we call it as unstructured data. And when I said that here, 66% of the data is coming from a relational database. So data is sitting in the relational data, and we are going to go directly to that data and then ask them to build the model, right, for the predictive analysis. All right. So right now, what we did is we just completed the basics of, I just gave you a small introduction about basic of machine learning process. Now the thought is, let's deep dive into machine learning on DB2, right? I'm sure what we are doing is we are jumping onto a DB2 platform on an AX server, and we'll see how this basically whatever we talked earlier is coming in, true picture in the part of demo, right? So the DB2, right? Right now, IBM released the latest. What I did is, this is the DB2 version 11.5.4. That's a version of DB2. So what IBM introduced is in the 11.54, they made the database as AI, and they call it as in-database machine learning process introduced into this particular version. If you go look for any version prior to 11.5.4, that this feature is not available. So if you are older version, still you need to use the traditional approach, right? What I showed earlier, you need to take the data, go through a Kafka streaming process and Apache and then multi-layer process. But if you upgrade your database to 11.5.4, that's where you see that the database is AI enabled, and you can do machine learning process. So these are the basic. When I showed initially the 6 steps, right? All the 6 steps covered. I can go back quick. These steps what I was talking about. All these steps, like 6 steps involved in machine learning process. So what IBM did is they introduced all these 6 steps in their database, right? Within the database. And what they did is, basically what we did is we introduced a set of stored procedures. So these are the stored procedures functions, right? I mean, it's like a call stored inbuilt stored procedures. With that, basically we call the procedures to build, different steps. So for exploring the data, we have a set of procedure. And pre-process or ETL transformation, we have a set of like a missing values, normalization, or whatever you want to do, you can do with that set of stored procedures. And the next level is the training the model, right? We train the model, and using the train. When I say train, this is where we build the model using basically IBM DB2 supports classification. In the classification, we have two types. One is the decision tree and naive-based modeling. And regression. For regression, we have a linear regression model, and the clustering, which is unsupervised. I mean, these two are supervised. And when I say clustering, K means there's an unsupervised. For that, we have a K means algorithm, right? So these algorithms are pre-built. IBM already built the algorithm for you, right? I mean, that algorithm sitting there as stored procedures. And as long as you, as a data scientist, you come to a company and you join as a data science scientist, as long as you're able to prep the data, what the data look like, and then you pre-process and you have the data set, you can send the data into using the process. You can using the existing algorithm, you can train the model, right? You can build and train the model, and you can evaluate. Again, when I say evaluation, that's where that classification. In the classification, we have a confusion matrix, accuracy, precision, recall. All these things you can do with the set of procedures, and as well as in the regression, you can do regression. You can do that. So and then in the inference, the last step, that's where you do the predictive analysis, and that also covers with the set of stored procedures. So what I'm trying to say is a set of procedures already built in, and you are going to use those procedures to do your entire from beginning to end of that life cycle of the machine learning process. So this is basically a database setup. So this is okay. When I say here install 11.5 Linux environment, it's not Linux. I mean, we did with the Linux one test case, and we got a Power 9 AIX server, right? I mean, I believe Ganesh told me that in Sastra also you folks are using AIX, 3 AIX servers sitting there. So we built in the AIX 7.2 and in a multi-8 processor server. What we did, we installed DB2 11.5 fixed pack 6 in our AIX server, and this is basically a set of once I enable that DB2 enable ML procedure, that's a registry value. When you set to yes, the database is automatically enabled for machine learning, and then we installed. This is a few steps, right? We basically build the database, and then within the database, I mean, if any database experts, if you are, I mean, the database, and it contains the table spaces inside, and we call a set of process to build all the. So in these steps, it builds that machine learning procedures, stored procedures. And then we'll give access to that procedure to everybody, and then that's it. So now all we did is in these steps is we installed a DB2 on the Power server, and we enabled the server for we enabled the database for machine learning, right? This is a simple setup. See how easy it is, right? Within a couple of few steps, you build basically you build a AI database now, right? So I just want to give you a use case scenario. As I was telling in the first beginning of this thing, right? I mean, so what I'm doing here is, I mean, anything you learn, you need to know what is the purpose, right? How this is getting used. So as I said, we are our largest, we are trucking, and we carry trucks, and we get a sensor data set, right? Data set coming from all the complete from our engine. So kind of this is a simple scenario I'm showing, like sensor data is coming from engine failures, because all the engines continuously feeding data to our system, and maintenance reminders. We'll get a constant maintenance reminders, and as well as the tire tread, right? I mean, involving our trucks are fitted with we call 18 wheelers. If you look at our trailer, it has 16 wheels, and then 2 wheels in the front, right? I mean, so basically we have 18 wheel trucks, and all the tires, right? That constantly we need to measure the tire tread wear, because if the wear goes down certain limit, we need to be alerted, and the driver has to take an immediately go to, because it will cost us a lot of money. I mean, we spend a lot of millions of dollars for accidents, right? If one accident costs us millions. So we try to avoid these things. The idea is constantly capture those tire tread wear pattern, and then and we want to do some predictive analysis. So the idea is we are getting all this data and feeding data into historical data into a IBM DB2 database, right? Which is in this case the 11.5.6 version, and in the database we use the historical data. We collect the historical data, we label the data, we classify, and we build a predictive model. And once the model is built, and we make sure that model is you won't get 100% accurate, agree, but we want to make it more accurate, right? Close to 90-95%. And then and the idea is once you build it, and any new data set comes in, right? When the truck is going on the route, any new data comes in from tire tread or maintenance reminder, anything coming in, if it matches the pattern, right? The model will go back and analyze the data, and if it matches based on the conditions, it will send an alert to that, to the engine, right? I mean, you might have seen, I mean, folks are driving AI right now. Google is releasing, as I said, that autonomous cars and stuff, right? They're all working the same pattern. I mean, here, one step down, we are going one step down, and we want to get constant alerts and, real-time alerts. Whatever you talk about, we'll be getting from that database when the trucks are going in the route. So I'm just giving a simple use case scenario. So to do this, what we're doing is, we are, as I said, we are constantly through real-time replication, right? We are when the data, because our trucks are fitted with Qualcomm unit. So Qualcomm is nothing but collecting the data. Data will go from the engine to Qualcomm, and Qualcomm it will send the data to our in-house centralized database repository, right? I mean, our data is sitting in in-house as well as cloud. So we'll be continuously gathering the data from trucks, and the trucks sense whenever there is, it's a continuous feed. We get millions and millions of sensor data continuously feeding to our database. And see, for this demo, what we did is we collected basically truck fleet data set, right? So if you look at it, these are, we call it as that. If you look at what I'm showing is a structure of a table, right? It's a CSV file. We get a CSV file and we loaded it to table. And anytime when you look at data set, the two components when you look for that supervised learning, right? One is a feature. Feature is the input. You pass a set of input, and then you label it, right? The output label. So building this input and label is a time-consuming process for data scientists. So what we do is going through a enormous process, right? That's why we spent like most of the time in capturing this input data. And for this, we classify, and then based on this data, for example, my engine RPM reads certain speed number, and load goes to certain above certain this thing, and there is no vibration, right? There's some certain number. Then at the time I want to show that the flag is, it requires the engine need a maintenance, right? Maintenance flag set to yes, yes. And if the levels are whatever the capture value is less than a threshold, then you don't need a maintenance flag. So the idea is we build this label the output before feeding the data, right? Before doing any analysis. First step is build this, collect this data set, and all this data set, what you're seeing is coming from trucks, right? Engine trucks. And I just want to show you a simple data set, how it looks like. So this is I'm just showing the data set, how it looks like. So engine load, RPM, speed, and all these. They're all coming with certain numbers. So if you look at the maintenance flag, this is the basically that's a label. So wherever you see 0, I mean, this table contains more than 7,000 rows. I'm just showing a sample data. And in this case, if these numbers are coming like this, and basically it says, label says, you don't need a maintenance, right? And there are rows in future, it will come, when the threshold value is coming as a different number, then it will show as it requires a maintenance, So I have both maintenance as well as not required maintenance. So this is where we collect and analyze and set up this, data set. So when I look for this exercise, right, for this demo, what we did is the 6 steps, right? We talked about all the 6 steps. All these steps, what we did is using these stored procedures, right? Was to visualize the data, we use summary, IDAX summary 1000, and feed the input data into this table. And we got that how the data looks like, visualized, right? The data can be, just by calling, this is the code, simple, see how simple it is. So with these 6 steps, with these 6, if your data is sitting in a database, with these 6 steps, basically you built a machine learning model, right? Pretty straightforward. So for the data transformation, we use a split data. There's a built-in procedure where you can just pass that to the procedure. You pass some in table and the train table, right? Training table, and then it will build that. It will split the data into whatever the fraction we need, right? And then in the naive base. So in this case, as I said, it's a classification model. We used a naive base algorithm and to build this model. So this is how we built the model, and we can name the model as whatever the name we want, and then input table and with the respective target. Target is a maintenance flag, and then some parameters. So with this simple step, basically you built you basically teach the machine or teach the model how the data looks like, and basically you create a brain of this machine learning process. So then you can print the model, and wherever I'm showing output, right? This is the output what I got it. And then predictive naive base, right? This is a procedure. With this procedure, so what I'm doing is with whatever the predictor model I built, I will send at the test data set, right? Test data set is nothing but what are the new data. I feed the new data, and then I will basically, this is what I'm predicting with the new data set. I'm predicting whether my truck need a maintenance or not without the label. When I say test data won't have the label, and it will go and read that model and run through the model, and it will alert for the result set. And then at the last, you basically built a confusion matrix. And if you're a statistics person, you know that confusion matrix is nothing but I will be finding out how many rows I matched, right? Again, I said, when I pass any test data set, it's not 100% accurate, right? I mean, you'll find some difference unless my model is 100% accurate, which is very difficult to do it. But in this case, this is the results that I got. When I pass 375 rows into that model, in this case, I got only 61 were coming as a difference, right? I couldn't match 61 rows. I couldn't match that condition. So which is like a 16% difference, right? And this is that outcome. Basically, this number says how many matched and how many didn't match. So this is the end of that confusion matrix. And what we'll do is, if this model doesn't, if even 16%, we can still improve. So what we do is we cleanse the data again. We send again. We get more accurate data. We go for and again. In this example, I used the 7,504 rows. This is the input data set. So we collect again more data set and more labeling, and then again run through the model. And this is like a cycle process. And until we get close to that, our idea is reduce this difference as small as possible, so that your model is more accurate. So that's the idea of this. All right, so let's. So whatever I mentioned here, I just want to visualize quick demo, and then okay. Before going to the demo, I'll just give you a real-time, the process. So why are we doing this, right? Why are we doing this? What do we gain? I mean, end of the day, when you are doing something which is the heavy process, you need to know what you're gaining, right? So in that basically I mean, again, as I said, it's machine learning can be applicable to any industries, any banking, logistics, and any industries you go for. It's a process applied. And recently, right? I mean, I go for any, like for example, you can be a mechanical engineer, you can be a computer science, you can be a civil, you can be electrical. You go for any engineering, right? Doesn't matter. And there is a data science components inbuilt. I mean, what I'm trying to show here, the predictive modeling is, why are we doing this in the tracking logistics? So I can say how long the truck can run without maintenance. I mean, based on the incoming data set, I can say my truck will reach the destination without any maintenance, right? I mean, as I said, we have 8,500 trucks. Today we have 10,000 drivers, right? And we continuously hire drivers, and we don't know in 10 years from now when we are looking for more autonomous trucks, right? There won't be the drivers will be sitting on the wheel. I mean, it's automatic. I mean, from East Coast to West Coast in the US, trucks will be going automatically. I mean, there will be one driver will be just sitting there just to monitor. So trucks will be going in autonomic. So in that case, we need to get more AI built in, right? So I need to say how long the truck can go without maintenance. And if the maintenance is required, immediately I will alert the truck, and then I will take it to a maintenance shop, right? So we can avoid a lot of costly maintenance money, the price. And then I can say, if I have, as I said, drivers, right? We are hiring drivers continuously. So if I have drivers information, correct drivers information coming from Facebook, Twitter, and our drivers constantly, they talk between each other. Based on the data, incoming data, I can say whether drivers can quit in next 30 days. So that's the one analysis going on. And I can immediately, if I know a particular driver is ready to quit in next 30 days, I will go back and make sure that he gets enough, fund and enough home time or whatever you call, and make sure that the driver doesn't quit this company, right? I mean, which we're spending a lot of money for driver turnover. And then company turnover in future. I mean, right now we are $2 billion company, and 10 years from now, if you have the right accounting data, I can directly go to my CIO and say that we are going to make this many billions, right? Based on the past history. And we can turn history accidents, and then tire tread. I told you tire tread failure analysis, and then battery life, because we have constantly changing the batteries, how long the battery can run without before going for change. So these are like a real-time use case scenarios. So let's just run to a quick demo, and then we'll open for QA session. Or if you don't have time, you can always reach through Ganesh and whoever your contacts, and you can ask questions, right? All right. Do you guys see a green screen? Can somebody speak? I want to make sure that my screen is shared. Okay, I will take it as yes. So this is basically the server. I'll show you. This is the Oregon server. I'll just connect again, just for the sake of. So basically right now, I'm connecting to the server in, so this is the Power 9 server, right? If you look at it, it's a Power 9.
No, I'm not able to see the screen. You are saying the terminal, right? Terminal is not visible. Only demo.
Oh, terminal is not. Oh, okay. What do you see, Ganesh?
Demo.
Oh,
like
demo. Okay,
slide.
hold on. Let me. I don't know what. Let me share the screen again. 1 second.
Yeah.
Do you see now?
Yes. And can you enlarge the font? Yeah.
Yeah. Well, let me connect again. Unfortunately, font size, right now. Can you guys see at least a little bit? Is it readable or it's too tiny?
No, I'm okay with this, but I'm not sure auditorium people can see it. When the team is able to see the screen here.
Actually, we are not able to see the font.
Oh, you cannot see the font?
No, sir.
Okay, so what we'll do is this is just for a demo. I'll just show because we already presented the information, but I'm just showing you running a script, right? I won't go deeper inside, but I'll show you a script and it will tell you an idea of what it does, right? So
and also team, we are also going to implement the similar scenario at your the Sastra cluster. You guys can go and experiment it also later on. Okay.
Yeah, we can share our scripts and the process and data set, Ganesh, for them, and we can guide them, right? How to set up and those things we can guide them. Okay, so let me see. Is it better now or no? Okay, that's fine. Just for the timing. See, is there anything we can do here? Once again, let me try that. I can change this. Is this better? Is it better, guys? It's a little bit bigger.
This one is better, actually.
Okay, good deal. Okay. So, as I said, this is I think, Ganesh, we got 10 more minutes, right? Okay, let me complete quickly. So this is our AIX server, and if you look at the date right now, it's December 7th, 2026. That's a West Coast time. So this is running on AIX 7.2. I think this is the same server what we have in our the Sastra lab. And if you look at the server, we have 64 CPUs configured, and we have 256 gig memory. And this server comes with GPU disk as well as the internal disk, right? So these are this disk setup. So what we did, if you go inside, so this is our instance, DB2 instance we built, right? So if you look at the DB2, the version is right now it's running on 11.5.6. So this is a latest version. And, this is my database. Basically, this is my database that's called DBSMPT, right? And there's an alias created for this database, and this is a name. So what I'm going to show is in that the machine learning. And before going for the exercise, again, I'm telling you guys, I mean, so again, machine learning is not only within the database DB2 machine learning. It's not just stopped with my DB2 functions. If you have a Python program, right? If you know Python, we can use Python code to build UDFs. You can through Python, you can build a model, and then you can bring the model into DB2 and then build through user-defined functions. You can do predictive analysis. So even though it's running on database, doesn't mean that you're just restricting yourself with what is IBM provided the modeling algorithm. There are various other ways you can build models. So in this case, just I'm showing you a predictive analysis here, right? Okay, so first thing is what I'm going to show you is okay. So what it's a simple, right? I'm dropping existing table if the table is any, and I'm building a table, right, with the structure of this all this incoming input data. And this is the where I'm showing the maintenance flag. There's a flag which is the label, and all others are the features, right? Input data set. And then once the table is built in the database, then this process, right? Import. Basically, I have a data set is sitting in a fleet. This is in a file. If you look at this one, this is a file, right? This is a file, comma separated file. I'm loading this data into that table. This input table, right? So if you run this right now, just first build this just for understanding. So this is where you're collecting data set, and okay, this is done. So I created the table here, and through the import process, I got a data set of 7,504 rows copied into this table fleet name base, right? So if you are a DB2, I mean, if you're a SQL guy, you do a select okay. Connected to the database. So you do this is a simple statement, right? When you do when you run a queries against database, select star from the table name. So in this case, I'm just fetch only first 1,000 rows, right? So what I'm showing is I have a data set coming in. It's a structured data set. I loaded the structured data into a table, the DB2 table, and I'm pulling the first 1,000 rows from the table. So when I run this, see this. This is a DB2 SQL query, which basically pulled 1,000 rows from the table, right? So this is basically loaded into the first thing. What we did is we loaded the data into a table, right? Once this loaded, I'll just quickly go through. I think we don't have enough time, but I'll just go through this setup. So we will drop anything already built, any drop model, old tables, we'll drop it. And then using these functions, right? I told you split data, like split data. We'll split the data from the input table into two output tables. One is a train table, and then one is test table. So in this case, I'm doing a 80%, right? Fraction 80. So I take that 80% data into a train data set. That's for the supervised learning. And then remaining 20% I will store in the test data set. And my idea is then I will query the tables, right? Here I'm querying the table. Then this is where I'm building the model, right? The naive-based model. This is where I'm building the model. This is the brain, right? This is the brain. I mean, see, the step is very straightforward. Once you know that calling stored procedures, this is pretty straightforward. Build the model. And then we will print the model, naive-based model here. And then again, we'll query the results, right? Naive-based result set, query that. And then we will, again, this is where when I say predictive naive-based, and this is where basically what you do is in this model, whatever the built-in model, you pass the input data set, right? That's input data set, not even test data set, which doesn't have a label, right? Or this is the real data, I mean, unknown data getting into the model, and it will predict that what is that, maintenance flag required or not. I mean, that's where that prediction happens. So see how easy to run a predictive model here. And then we'll compare these two tables, right? And then find out actual and predicted values. We will compare the data set, right? Between that, what we had earlier stored and what is the outcome from that new model. And then the last step, this is where we are building the, called the confusion matrix. As I said, this will tell us how many rows matched, right? How many rows matched predicted and then how many rows didn't get matched. So that's a confusion matrix. So let me run the script. It will take a couple of minutes. So I'll show you. And again, this is running on a Power 9 processor server. And then as you add more cores and more processors, more parallel disk, the performance will be much faster, right? And one more thing I want to mention is, as I showed you, got the table, right? It is the input table. Okay, as I showed the input tables, think about, these are the features I'm input values I'm passing. So basically, to build this flag, right, to learn this flag, it will take longer. More feature you add, more it takes longer to build the model because it has to go through so many. The model has to go through and more statistics, like combination of you do a lot of matrix multiplication and does a lot of things inside. And more you add more features. I mean, we always in the model we want to reduce the number of features so that your model will run quicker. But if you add more complex features, building will be taking longer. And I mean, more feature will help us to predict accurately, right? You're giving more numbers, but it takes longer time to build, and the accuracy of the model is more accurate. So let's just jump onto that. I'm going to run this script right now. Whatever I showed you. All right. So it basically, as I showed you, it has it dropped everything and it called this split data, and it split the data into train data set as well as out of 7,504 rows, right? It split the data into 6,004 and 1,500, right? Train and test. And this is a brain. Right now, its model is building model, right? With this train data set, it's reading the train data table and combining all the features. Wow, it's completed. So this is the model size, right? And it built the model, and now it printed the model. Basically, this is the maintenance flag, and then it says what is the model looks like. Now here, what we are doing is basically in the model we are passing the test data set, which should not have, basically it's not reading the maintenance flag here. We're passing the data, and you're going to predict. We are asking the model to predict what is the outcome, right? So that's what running right now. And yeah, it's finished. And yep, bingo, it's all done. So what I did is the process basically built the model and printed the model, and then here basically it's a I call the predictor model, right? It's a predictive naive-Bayes, and then this is a result set table, and then I compared the data set between the result set and the base value, and which is here, right? And at the end, I will plot the confusion matrix, right? So here, this is the confusion matrix. So in the confusion matrix, what I did is the matched. So this is any real data which is requires maintenance flag, which is not required maintenance flag, matched 995 records matched, and then this is not matched. So 194 records didn't match. Same way, it's maintenance flag required is matched, like 283 records matched, and 28 records didn't match. So with this, my model is still little out of number. I need to still tune it with more input data set, right? So as I said, this is just giving an example of this thing, and this is what I'm showing is that in this case I got 14% difference, right? So I mean, 40% is there's the difference in data. So now I need to further tune the model with the new data set, or increase my volume, or whatever, we play with that. So this is just, I'm showing a real time analysis, and then this is where right now running on Power 9, and we'll be doing more analysis on Power 10, and then see how it goes. And again, this is a simple classification model I built. And if you have the right data set, we can do regression analysis, k-means, with clustering. So all these things you can do within DB2. And we will help you guys in Sastra, as Ganesh was mentioning. We'll help you to build a database DB2 and system, and we can collaborate and experiment the data, right? If you have a any data set, think about it. Again, as I mentioned, you don't need to be a computer scientist or this thing. You name it. I mean, if you're a mechanical engineer, if you're doing any projects, and then if you have a real data set, we can pull the data set and build whatever you need to do some predictive modeling. And so with that, I think we are 4 minutes delay. I'm sorry about it. And you can ask if you have any questions, and question and answer you can ask.
Shiva, thank you for a wonderful presentation. This is very important, for the people who are participating, as faculties, researchers, and students to get onto this DB2 with machine learning, kind of an enterprise, kind of a, infrastructure opportunity here. And this is going to be really helpful, for the kids and, for the students here. And I really appreciate your time with your real-time experience, which you shared in last 64 minutes. And now there are some questions. Suddenly, there are people asking already. What is state? One question from Kavita. What is state? State is a database name. She's asking. Maybe.
Okay. What's the question again, Ganesh?
What is state? State.
State.
Something, yeah.
State. I'm not getting that. State.
Somewhere you might have mentioned in between, in your talk, but I'm not sure.
And you mean? Hold on. You're talking about state.
Question. No. Kavita responded. You connected through DB2.
Yeah.
She's saying you connected through DB2, and that is what is state? I'm not sure how it is correlated to connecting.
Okay. So I'm talking about this is a database environment, DB2 environment, right? DB2. So this is a DB2. Are you looking for a DB2 version? State? I mean,
no. Let's move on. Maybe let's not hang up on this.
Okay, yeah. You guys can send me questions through email, right? I can.
Sure. We'll do that. And then the second question is, for handling big data, is it not required any MapReduce CUDA programming? Sir, that's like, they're asking a question. For handling big data, so the MapReduce and CUDA programming not required?
Not okay. It's a very good question, guys. I mean, so the IBM, when I said big data, right? Right now we call this database DB2 Blue. So BLU, the name is Blue. That's what IBM is, branding. So Blue is nothing but big data, and L is lightning fast, and U is ultra easy, right? That's how we branding. So you don't need to have a separate programming knowledge or kudos or Hadoop or you name it, right? I mean, there are all these things because IBM DB2 can store billions and billions of data, right? You can store within the database as a structured data set. So you don't need to go for programming MapReduce or MapR or JSON, nothing is required. So in this case, you're playing with directly loading data into a structural, as I showed you, feeding the data directly into a structural database, and then DB2 does everything. So you can say DB2 is the big database and big data database. That's a very good question, Manish.
Okay, thank you. He said, and the second question is for streaming data, how to pass it to our model?
Okay, So the idea is, so once you build the model, right? I mean, as I was saying, once the build this model, right? Here, so I will write, what I will do is, so if we do that, what I'm showing you is, this is a table set, right? What is the table name? So once you build this name-based model, right? When the model is built, right? What I'll do is in this predictive analysis, see this predictive I showed you, predictive analysis, what I used is, all I did is the model name, whatever the built model, and then all I'm passing is the new data set, right? New data set, I'm passing the new data set. So our idea is, if you look at this table, so this is the existing data set, right? If you pass, if you set up a data replication, like you can do always real-time data replication. As in this case scenario, I was showing data coming from trucks through Qualcomm, and you can use Replicate One or Oracle, or if you go to the different databases. But here we are Replicate One, and IBM also have a lot of replication tools. So you feed the data into this these unknown values, and then here, right, the maintenance flag, you can build a trigger. Within the trigger, and through the trigger, you can call that model name, right? The model. So what we are doing is, any new data comes in, immediately we pass to the trigger, and then trigger will call the model, and it will update that maintenance flag is yes or no, right? So the thought is, you continuously feeding data, and you're continuously building that model and calling that, adding that respective column to the maintenance flag. So it's pretty straightforward process, and I hope I answered the question. But this is what we do for streaming and replicating data into that the table. Does it clear, Ganesh?
Yes, Shiva, it's very good actually. Thanks for
Yeah, I can. So we can hook up. So what I can do, Ganesh, I mean, once we built a small system on the university, we can hook up and
Yeah, we can take it to multiple universities also in India. Actually, many people can get benefits about the DB2 and power system and all. Okay.
Yeah. Again, I said that you don't need a costly MapReduce, Kudos, or Hadoop, and you don't need all those systems. It's all building with a structured data set. So you don't need to worry about knowing. See, in this case, I didn't show you any costly programming, right? I didn't show you Java, or I didn't show you Python or MapReduce. Nothing. I mean, it's all pretty straightforward. You're playing with IBM DB2, and then you're building. I mean, as I said, Power 10 is coming up, and then you add more processor, and you're making your system bigger and bigger, and scaling the system. You can do, again, I scale the system vertical, or you can scale the system horizontally, adding more servers into the loop, and then you can make it like a you don't need to worry about MapReduce or partition the data or anything. You just do everything within the database.
Very good. Okay, thank you, Shiva. Thank you for the wonderful talk during your evening time. Really special thanks to you, Vinay. Please, go ahead and conclude the session of Shiva, Dr. Shiva.
Yeah. Thank you so much, Shiva, sir. Thank you for the informative presentation, actually.